So you read about this scientist that is doing a pretty simple experiment. And she wants to know about how color of light will affect plant growth. And so she set up this experiment, grew these two plants, and then at the end of the experiment found that plant 1 on the left up there grew 10 centimeters, and plant 2 grew 5 centimeters. So her conclusion was that plants grow better under red light. What are your thoughts about this conclusion? Sage?
She should have used the 0 amounts of water and the save plant so she could know for sure if it's just the light affecting it, because she used different water.
Yeah, she should use different
And
water.
it's a lily and a white, so that's
And the plants are different too. Okay, what else do you say? Maddie?
She gave plant 1 2 weeks and plant 2 1 week.
Yeah, that's a little weird. Jake?
The temperature is different.
Okay, yeah. So, is her conclusion, is it valid?
No.
No. So it's not a valid conclusion because of all those factors you guys were just describing. So, improve upon her experiment. And that box, tell me, how would you do it differently? Okay. Tell me, what would you do with plant 1 and plant 2 with regard to those 5 things that we call variables, those 5 factors in the experiment that we could alter? All right. So, how do we change it? Who could sort of summarize? Caitlin?
You make it so like the amount of time are the same, like the amount of water and like the temperature is the same, so that it gives more of an accurate.
Should anything be different, or should they be exactly the same? What?
Most of the things should be the same except for the light, because that's the Holy Spirit.
Yeah, so we would want everything to be the same. The only thing we really want to be different in this experiment is the color of the light, because that's, like we said, that's what we would be testing. Now, it doesn't really matter. You could have said half a liter for both, or you could have said 15 degrees Celsius for the temperature. As long as all of the conditions, except for the color of the light, are consistent, then we could say this is a good experiment, a valid experiment, and we can then rely on the results. So if we had done the experiment this way and saw the same results, then we would say it is a valid conclusion. It would make sense based on what we did. All right, so this, you guys already know a lot about the scientific method, obviously. You know that you have to control most of the variables. You want only one thing to be different when you are setting up a good experiment. And that's what we're going to be talking about for the next couple days. Okay? How do we set up experiments? What are the steps we follow? So there's lots of ways scientists do experiments and learn new information. We're going to say that we call this the scientific method, but there's not really just one scientific method. Scientists can follow a whole variety of patterns to find new information. We sort of picked one as a model to help you understand experiments, but this isn't the only list of steps, or the order can be changed and the order is flexible. So to help you remember the steps, because you are going to have to remember them in order, we could just remember this simple phrase: people really hate elephants on cars. Or if you're a visual person, you might remember this picture of Mr. Arcuri standing on top of the car. And that could help you to remember the steps of the scientific method. let's see if you could guess what some of these are stand for. I don't know what the P might stand for. Sophia?
Predict?
Close, but there's going to be another one that's kind of like predict. So the first one's not predict. Even though we talked about that the first day. And we got a different one? Start with a problem. So yeah, these are some things you can write, you could fill in your notes. How about the R? Mitchell?
Research.
Yeah, research. We'll talk about what we actually mean and what these things, how they relate to experiments in a minute. Lots of people are going to know the H. Olympia? Hypothesis. I think you'll get the E. Devin? Experiment. Balthazar? Observation. And finally, Layla? Conclusion, good. Problem, research, hypothesis, experiment, observation, and conclusion. So we'll ask you about these steps in your quiz coming up next week. And you should have to be able to list the steps and understand what the different steps actually mean. All right. Questions there? Okay. Well, there's another picture for you, if you'd rather remember that one. All right. So what do we actually do in these steps of the scientific method? Well, we'll define each one and talk about them. But the problem stage is when typically we ask a question. So the problem stage, we ask a question that we're trying to answer. Like the girl in the experiment we just learned about, she was asking a question, how does the color of light affect the growth of plants? So the problem is the question you're asking. But before you really can get into it, you might have to do some research. You might have to find some background knowledge about the topic you're studying. Gather some information. So if you're doing that plant experiment, you might know what type of soil, or where can I buy these plants, or what are the different types of lilies I might use. You might need some information before you can set up the experiment. So we call that step the research step. Once you have that background knowledge, you can then start to formulate what we call a hypothesis. Now, if I asked you guys for a definition, I know probably almost all of you are going to raise your hand and give me the same answer. Who could give me an answer you've learned about what a hypothesis is? Okay. So, put your hand down if you're going to say an educated guess. Okay, we have other definitions? Okay. What is another definition here? Danielle?
A guess.
Well, not a guess. Don't use the word guess or educated in your answer. Okay. Maya?
A prediction.
Okay, good. I like that better. So yes, you did learn, I know, in elementary school, a hypothesis, educated guess. But we're going to use a more advanced definition now. If that wasn't really wrong, well, we can be a little bit more exact now. So when we formulate a hypothesis, what we're doing is we're making a prediction. We're saying, okay, I'm going to set up this experiment, and this is what I predict the outcomes are going to be. When the girl set up that plant experiment, maybe it didn't say what her hypothesis was, but it could have been plants will grow better under red light. Or maybe it would have been plants will grow taller under blue light. Or it could have been the color of light will not affect the growth of things. But you make a prediction before you even do the experiment. Are you guaranteed that it will be correct? Is it okay if it's incorrect? If you do your experiment and find out it wasn't correct, you go back and change what you wrote? No. It's okay. If your hypothesis is incorrect, have you still learned something? Yeah, you still have learned something in the experiment. You still have gathered some new information. So it's okay that a hypothesis is incorrect. How an experiment? What exactly is an experiment? Why? Yeah, it's a procedure that you follow that you use to test your hypothesis. So what we read about earlier today was an experiment the girls set up to test your hypothesis. Procedure in which you carefully manage the variables so that you can test your hypothesis. Once you have conducted your experiment, you would be making some observations. What are observations in an experiment? What's an observation? Jack?
A observation is what happened during the experiment?
Yeah, and it's you might think of it as data that you're collecting. You might be using a tool to measure something. You might be counting. You might be measuring things with a ruler or a balance. So basically the observations are the data coming in from your experiment. What were the observations the girl made in the experiment we just referred to? What were her observations? What were her observations? Okay.
That the red plant, or the plant 1 grew 10 centimeters and the plant 2 grew 5.
Yeah, that observation she made were the height of the plants. That's what she had measured. And so then the final part here in our experimental method is to make a conclusion. What do you do in the conclusion stage of an experiment? Sophia?
You figure out what happened in the experiment and how you could do it better.
Okay, yeah, you might improve upon it. You also make a decision about something. What do you make a decision about, Sage?
Whether your hypothesis was correct or not.
Yeah, you say, okay, here's my observations. Here was my hypothesis. Was my hypothesis correct? Or it's better to say, was my hypothesis supported by this experiment, by the data that I collected? Any question about the steps of the scientific method or what they mean? Well, tomorrow we're going to look at some examples of these and how the scientific method is used in science. And we'll talk a little bit about variables and designing a valid experiment. But that's all for today. You guys want to say hello to YouTube?
Yeah.
Go ahead. 1, 2, 3.